We're getting a little bit better at these things now. We understand that we need a lot of information. We have to think through our problems before we jump in with our calculator. So at this point, I'm not going to write given, required, analysis, substitute, solve. I'm just going to assume that we kind of know what these steps mean. So I'm just going to write grass down the side. I'm going to try and fill in all the information I can and work through this one. Given. First thing that I see for given is I like numbers. I'll jump to the number that's given to us. So I'm going to write 3.41 times 10 to the 23. And this is a unit. Molecules is the unit. It's just counting. Molecules. This is just the number of molecules. So my symbol is simply number sign here. That's a number of molecules. So your unit will change. If that was the number of ions or the number of basketballs, you would just write down whatever you're counting. Okay. When you have the unit of dozen, you could have a dozen donuts, you could have a dozen eggs, you could have something. So the unit there would be eggs. You've got 12 eggs. You've got donuts, 12 donuts. In this case, it's molecules or ions or atoms or compounds, whatever you've got. Okay, so I got the number of. Determine the mass. Well, that's obviously required. What is the mass? I don't know, but it has a unit of gram. And at this point, we probably recognize that most of these things require molar mass. I usually write molar mass here and leave it blank unless I need it. If I need it, I'll calculate it. It's just there to remind me that I can get it. Alright, so this is what we want. We want to arrange our equation to solve for mass. I showed you before, grams per mole. Mass divided by moles is molar mass. Okay, so if I'm looking for mass, moles is N. It's moles times molar mass equals the moles times the molar mass. Now, since I'm only dealing with N2I6, I'm not going to write N2I6 down here, but it's not a bad idea to do that to keep everything straight. I'm trying to keep it as clean as possible, but you could write subscript, but since I'm only dealing with one thing, then I don't really need to do that. Okay, so now it's just substitute in. I substitute in the moles, the moles. I don't have the moles. I need the moles. I need the moles. If I need the moles, that means it's a required, not a given. I need the moles. I need the moles of N2I6 in order to substitute into this equation. So I can put them here. I don't have anything right there. But I can find the molar mass, and I've already found the molar mass, so I'm going to write that in here. 789.44022 grams per mole. As long as you got units up here at givens and units down here at solve, I won't require them inside there, but you do have to show what they are before you put them in, and you do definitely need units at the end. So I calculated that out. So I'm going to write it right in here because I know I'm going to need it. 9.44022. But I don't have the moles. If I had the moles, I could do this. So what does that mean? It means that I got to come over here now. There's got to be another equation that I can use. Now this is one way to find mole. But when I defined what a mole was, we told you that Avogadro's number, 6.02 times 10 to the 23, molecules per mole, or atoms per mole, or basketballs per mole. 6.02 times 10 to the 23 was this magic number that if we had that made our atomic mass is able to calculate here this molar mass. And so I do know that is in molecules per mole. So molecules is the number over mole. So the number of something over moles, the molecules per mole is something, that's a unit. And what is it? It's Avogadro's number. It's the unit of Avogadro's number. So I just derived my other triangle here. So this mole and this mole is the same number of moles, just calculated differently. So these guys actually link to each other. So if I solve for n here, I can then go and put it into this triangle here and put it in over here, and I solve my whole problem. So on this arrange step, I actually need to do number divided by Avogadro's number. Alright, so let's go and plug in. The number of molecules is 3.41 times 10 to the 23 divided by Avogadro's number. If I'm going to substitute, I need to put it here. Avogadro's number is 6.02 times 10 to the 23 molecules per mole, 6.02 times 10 to the 23 equals. Now, before I do my math, it's always good to know what I should be expecting down here. Even if I don't really understand what's going on, if I divide by something that's the same, it cancels out. So I should recognize that from math. Times 10 to the 23 isn't the same as an x, but that's the same idea. That's going to go away. So then my real math is 3.41 divided by 6.02. 3 divided by 6 is about a half. This is 3.4, so it's higher than a half. So I should get a number around a half, but bigger than a half, with no 10s to the 23 because they cancel. So I'm going to type in 3.14 or 3.41 EE or EXP 23 divided by 6.02 EE or EXP 23 because EE and EXP mean times 10 to. But that's in calculator, so don't ever write E's to me. Okay, that's calculator. We write in math, but that's how it actually interprets it. That's how it sees it. So I type that in, and the number that I got is bigger than a half, but pretty close. 0.56644518 moles. It's amount, moles. Okay, don't round here. Okay, yes, we're going to have sig figs. Yes, most of those are not significant. We learned that yesterday when we were talking about all of our sig figs and measuring. But right now you want to keep all the digits you can. If I round at this step and this step and this step and this step, if I round all the way down, my final answer is going to be so far away from the right answer that it's completely insignificant. We keep as many digits as we can, and then we apply significance down here at the end. Okay, so keep all those. That being said, I don't know if I left enough space. I'm going to put as many of those as I can. But even if I don't write it here, I'm going to use it. 566.44518. I fit it in. Now I can type it into my calculator. Now I can solve for the mass of N2I6 in this number of molecules. And I get 447.1746097 grams. We've solved our problem, solved our problem. But before I go ahead and finish, before I do this, I don't need a therefore statement because this is a simple, straightforward answer. If it was kind of a paragraph, we'd add a therefore. I don't need that, but I do need to look up here. I have 3 measured values, 3.41 times 10 to the 23 molecules. That means this one can have 3. So I'm just going to rewrite my answer, 447 grams. That's as close as I can know it. In this case, because there's 3 spots, I don't lose any value in 447. It is 3 digits. This is 3 digits. We're okay. If you want to put it into scientific notation, that's fine. 4.47 times 10 to the 2 grams. Alright, I would just put this in. As long as you don't lose your significant figures, you can keep them all. Writing things in this at times 10 to the 1, times 10 to the 2, even times 10 to the 3, usually we will just change the unit to kilogram and keep values, but we use scientific notation for things that are crazy like 10 to the 23 or even 10 to the 5, 10 to the 6, stuff that we would need. So 447 grams are in 3.41 times 10 to the 23 molecules.